customize के बारे में कैसे मैच करें।
Yeah, hello everyone. Very good morning to all. I can see everyone name who joined with the one plus name. May I know your name, please? Appreciate if you can change your name or let me know I can change your name. So at least we can have the bi-directional discussion. Someone joined with the one plus name. May I know your name, please? Good morning, everyone. I'm just talking with one plus who joined with one plus name. I think he dropped. Okay, no problem. All right, guys. So in previous lecture, right, we had a discussion about the single pass architecture with flow logic. So you guys have any questions regarding that? Because we have detailed discussion how the parallel processing is going to be happen with single pass architecture, that is Japan OS, and how the step-by-step flow logic is going to be look like. Means when the packet is going to hit to the firewall, how the firewall is going to treat those packet. So please let me know if anyone having any question so I can move further. We also discuss about one of the simple lab. We discuss about the zone, right? How zone is going to look like. So we even discuss about the zone part, right? So if anyone have any question, let me know because today I'm going to do discussion about again the layer 2 lab topology. Let me see. And also what I'll do, let me stop it. There are two PC. There is one of DHCP server as well. Okay. So what I'm going to discuss during the first half, how the inter-VLAN routing is going to happen with the help of the Palo Alto Firewall. That's the one thing. Inter-VLAN routing. Then I will discuss how to integrate the DHCP and then how the PC is going to get IP address in DHCP. There's two type of DHCP. One is my Palo Alto is going to act as a DHCP, right? Means Palo Alto Firewall is a DHCP server like routers and switches. And another use case we are going to discuss it. Palo Alto is going to act as a relay agent. Means like a IP helper I need to configure, then how it is going to reach a DHCP server and then it is going to get IP. So we have the external DHCP. So that's why in a lab you can see here we have the external DHCP server. So one time my Palo Alto itself is going to become as a DHCP server. That's a first use case. And the second use case, this is going to act as a relay agent, right? And this is going to do the packet forwarding from this to this, and this is going to release the IP address. External data center base my DHCP server. So very first thing, right? In last session, we had one discussion. Let's suppose we have one of the firewall similar to the switch, right? We know what is the switch. I have the two PCs, the PC1 or PCA, and I have the PCB. This was having the IP address 10.10.10/24. This one IP address 10.10.10.11/24. We put both VLAN under the VLAN 10. Means these ports are going to be access port. This is also going to be access port. That is a VLAN port 10. This is the access port. This is also access port, right? And the switch is purely layer 2. So we can make the communication because they are going to stay both of the port. Let's suppose this is GE 0/0 and this is GE 0/1. So both are going to stay in the same broadcast. And based on that, they are going to make a communication. Same thing, we replace this switch with the firewall, that is a Palo Alto firewall, and Palo Alto firewall exactly work as the layer 2. And we did the lab also. And based on that layer 2, what happened? We make the Palo Alto interface, this PA interface. This is as a one VLAN. This is another means same VLAN, VLAN 10 and VLAN 10, but we just restrict the communication based on the zone. And we did the lab. That is a layer 2 mode of deployment, right? So we have done this layer 2 mode of deployment. Now what I'm going to do discussion today, let's suppose I have the switch. That's my layer 2 switch. Okay. This is layer 2 switch. This switch have the two PC connected here. But this time one PC have the IP address /24. This is my PCA. This PC is having the IP address like 20, 20, 20, 24. This is going to be VLAN 10 port. This is going to be VLAN 20 port. This is the layer 2 switch. Can we make this communication? Can someone tell me, is it possible to have a communication with the help of this switch? Anyone, guys?
Yes, sir. We have to do routing on switch.
But this is a layer 2 switch, no? I mentioned this is a pure layer 2 switch. So can layer 2 switch support the routing?
No.
No, sir.
No, sir. It's not supported.
So is it possible or not?
But yes, it is possible with internet VLAN routing because you can make
Possible
it
with the help
port.
of the interval and routing, right?
Yes.
Give me 1 second, guys. Hold on. Still, I'm just fixing. Let me see what's happened. Please mute, guys. Just give me 1 minute. Let me see what happened. Why I'm not able to access this lab. Right? Yeah, it's working now. So we discussed about the inter-VLAN routing is going to required, and without inter-VLAN routing is not going to means what is inter-VLAN routing and what exactly we have to do here to make this workable? Anyone? What exactly I have to do here so that this is going to work? Do I need additional device or not? Or only possible to make this communication? I have the layer 2 switch, but I want to make this communication. So how basically you guys are going to do that? Any idea?
Yes, I think we need to create one interface as a trunk.
Mm-hmm.
Then we can communicate from one VLAN to
And
another VLAN.
so where this trunk is going to be connected?
Yes, router.
Router. Okay. So basically in this scenario, the switch is just layer 2. So this is not going to make a communication to different segment, right? They have the intelligence to understand the VLAN, but not the network. So that's why we require the layer 3 device. This could be the router, or might be we can get the layer 3 switch as well. So if there's a layer 3 switch, also it is possible. So that we have to make a trunk, and then we know this is a inter VLAN routing, right? That also known as the router on the stick,
Yes.
right? You guys have heard about it, right? Router on a stick, inter-VLAN routing.
Yes.
Now the very important question: how many of you know about what is the VLAN? What is the VLAN and why we use the VLAN? Anyone able to define what is the VLAN and why we use the VLAN?
We can divide a single broadcast domain into multiple broadcast domain via VLAN, I think.
Okay. Any other? Why VLAN? What is the VLAN? CCNA, I believe, right? You guys know what. Madan, what is the VLAN? Anurag, what is the VLAN? Anyone? I get one answer. Just divide the broadcast domain into multiple subdomains. What is the full form of the VLAN? Anyone know?
Virtual local area network, I think.
Okay.
Virtual LAN.
Virtual LAN. That is known as the virtual network within LAN, or that is the virtual LAN, right? That's the correct local area network or virtual network. We can do that. So technically we know VLAN as a virtual local area network, right? It's the correct statement. That is the virtual network is going to be created. So see guys, VLAN is basically used for the logical segmentations. what is the logical segmentation? What is the physical segmentation? There is two words. One is the logical segmentation and one is the physical segmentation. Anyone know what is the segmentation? What is the physical? Might be you can explain what is the physical segmentations. Anyone can define what is the physical segmentations? Very simple example. Let's suppose any family have two brothers and they have the big house, right? So they'd have to divide the house. That's the house is the physical entity, right? So they will split the house in the two part. So that first part is going to one brother, second part is going to another brother. So that's the physical segmentation. Means we divide the house in two part, and now you are with the one isolated unit, another is going to be another isolated unit. So that's the how physical segmentation is going to be happen. Or take an example. Let's suppose you have the one bucket of the tomato or potato and you are going to just do divide into two part or three part. That's the physical segmentations. Or might be you have some long stick you want to divide into multiple sub sticks, then you have to just cut it down and you can just do that. That's the physical segmentations. But when we talk about the logical segmentations, that means my resources, let's suppose take an example for this house itself. Physically, it's not going to divide it in any subpart. Physically, it's not going to divide any subpart, but logically, we have to define some boundary, and that boundary is not visible to you. But still, that is going to work, right? Might be we can do some kind of infrared in between these two houses. If you're going to cross this infrared, you are going to might be harm ray is going to be there. Might be electric is going to be there. That is invisible to you. And if you're going to pass, you're going to get shocked, right? So this is how just layman example, but this is not exactly logical segmentation is going to happen. Logical segmentation is, let's suppose you have one switch. This switch have the multiple ports, right? And by default, they are the physical ports. But let's suppose I want to divide this type of port for the HR, this for the IT people, this for the sales people. So switch is the one and they have the all physical port. So I cannot just go say, hey, HR people, you can use this port for your purpose. I can use this port for this purpose, this port for this purpose. It is not going to work. If I connect the PC, if there is no logical segmentation, the IT people is going to talk to the sales people. Sales people is going to talk to the HR people, because by default, all switch port is going to in the same VLANs, right? So to make it happen, to make it segregations, we have to use the logical segmentation. So that means you have to create some sort of the logical network that is going to divide your one broadcast network into multiple sub broadcast network. Let me explain what does mean. So what is the one broadcast network and how it is going to divide into the multiple broadcast? Let's suppose we have this subnet 192.168.10.0/24. Let's suppose this subnet and you assign the VLAN 10. This is going to part of the VLAN 10. Now this is one of the switch. This switch is going to be there. They have the multiple ports, right? The switch have the multiple ports. I'm just drawing the port for reference. It is not going to like everywhere port is going to be there. Switch, you're going to find the front end port, but I'm just showing that for reference. Here are the ports. So if I just go and configure the all ports under the VLAN 10, so if this area belong to the sales, this area belong to the HR, this area belong to the IT people, and this area belong to the marketing people, they all are going to belong in the same domain. So if they are going to belong in the same domain, same VLAN, so they are in the same broadcast network. So if they are in the same broadcast network, they can talk to each other. Means there is no boundary. Even I just divide the area, this area is for the IT, this area for the HR, but still they are going to talk to each other. Still they have the capability to talk to each other. So that's not going to create a lot of differences. Still you are in the same network. But what if I split this network into multiple network? Let's suppose I divide this network in two parts. So you must know the subnetting. I'm not going to teach the subnetting, but just take an example. So I make one network 192.168.10.0/25. Okay. Another network I create. Please mute Ayyappan and Madan. 192.168.10.128/25. So I split this bigger network into two part. Okay. Similarly, you can split into the 4 part, 8 part, multiple part you can divide. So now I have the two sub network, and for this I divide the VLAN 20, and this I divide the VLAN 10. Now, if I go and try to configure the same network for the HR, this is going to be the HR, this is going to be IT. So they cannot talk to each other because they logically segregated the one bigger network into two network. That's the segmentation of the broadcast domain. Means we just divided the broadcast and logically we separated. We told this port is going to part of this subnet. These ports are going to part of this subnet. So this is how it is going to happen. So in short, if I talk, VLAN is the virtual local network. It's a logical segmentation of the physical network into multiple isolated broadcast domain. It allows different devices on the same physical switch or the multiple switch to communicate freely in the separate network, right? And by using the VLAN, you are going to get more organized network. Means you have the very organized network. You can different subnet are going to be isolated. You have the improved performance of the network, right? Network performance is going to be improved. So that is going to happen. And also you are going to enhance the security. So these features are going to happen. So these VLANs we can configure in the Palo Alto Firewall as well. I just give a bit of idea. But if you want to do the configuration on the Palo Alto, this is also possible. You can configure this VLAN on the Palo Alto Firewall. Anyone have any questions, guys, still here, or everyone is happy? Please let me know. All good. Give me thumbs up if you understand this concept little bit, VLAN. I'm assuming everyone know about this in the CCNA, but I just given a brief idea. Now let me show you how this VLAN is going to be configured in the Palo Alto Firewall. That's our lab we have to do in this session. So you have to put admin, password again admin, and then we have to change the password. So I'll put the old password again and I'll put the new password. Oh, sorry. Something went wrong. I believe now it's done. Okay. So you check source system info. You can verify what IP it is getting by management interface. So you guys can do all labs by using this management PC. This management PC you just turn on and you can log into the firewall in the browsers. So you just have to check what is the IP there. So right now I'm getting this IP address. So I'm in the LAN network. So I can simply go here and log in this IP address. So I'll put here 192 and this is going to be 184. And I'll put the HTTP. So my firewall is going to be login here. And then I'll put the username, password. And meanwhile, it's booting up. We can go on the PCs and we can set up some IPs. Okay. And we need to configure the switch as well. So this PC have the different IP and previous PC have the different. This is a 10, this is a 20. So let me put it here again. And I'll go here. You just go in the network. Okay. After going network, just go in the adapter settings. Go in this communication properties. We are building the very basic foundation, guys. So you guys can understand how the step by step is going to be configured. So I'll configure this IP. Gateway is going to be on the firewall because we have to talk in two different networks. So gateway is always important. Without gateway, you cannot talk to a different network. First, you have to reach the L3 device. Then your L3 device is going to route the packet to the destination network. So in that case, firewall is going to be there. So that's why I need to use this 10.10. Subnet mask is going to be 255 and the 1. DNS not required for time being, but this is the gateway. Okay, so I'll done. Second important thing, because if you try to ping from this PC to this PC, once we have the successful configuration on the Palo Alto Firewall, it is not going to allow because they have the firewall enable on the PC, they block the ICMP. So it's always a good choice to go and disable the firewalls. So go here and you can just turn off the firewall from all section. Make sure it's turned off. Already have done to just save the time, but you guys have to make sure it should be done. Now, after this, you have to move in the PC4 as well. This PC4, we have to set up some sort of the IP address. So I'll go here, properties, adapter. This is my property. And this is going to be 20, 20, 20, 20. This is going to be 20, 20, 20.1. This is also done. I'll make sure firewall should be also disabled here. Both sides should be disabled. It's already done by me, but let me show you how it is going to look like. Somebody pasted something. Okay. So now you can see the firewall is disabled, so we are good. Now we have to do the switch configuration. This is your layer 2 switch, right? So this layer 2 switch, what we have to do that, basically you have to configure this port under the VLAN 10. This is going to part of the under the VLAN 20. So we have to create two VLAN 10 here and 20 on the switch. This is going, both ports are going to be as an access port, but different VLANs. Okay. But this have to pass the two VLANs. So this is going to be trunk port. Trunk port is going to pass the multiple VLANs. So I need to configure the switch in two category. So I'll go here. And I'll go in config T and I'll create the VLAN 10 and I'll exit and I'll create the VLAN 20. Now after this, I'll go on the interface and this interface need to be put on the VLAN 10, Ethernet 1. So ETA 0x1, switch port mode access, switch port access, VLAN 10 and no shut. This is the one port. Another port I have to do that. This is another port, that is the 0x2. So switch port mode access, switch port access, VLAN 20, no shut. This is also done. Now we have to create this port as a trunk port because we have to pass the both VLAN on this particular port. So I'll go on the interface. This is my interface. This interface is going to be Ethernet 0x0. So ETA 0x0 and switch port mode access, sorry, switch port mode trunk, right? And switch port trunk allowed VLAN 10, 20, both I want to allow. Another command you might be, you're going to get some warning. So you have to add switch port trunk encapsulation.1q. So you make sure if this above two commands is not working in some switches, so you add this command. This is a legacy command. Sometime it is going to require. So you have to do that. So now my configuration is done. Let me write the configuration. Let me do the verification. Show VLAN brief. We are going to get, there are two VLAN 10 and 20 has been created. VLAN 10 is part of the Ethernet 0x1. 20 is part of the VLAN 0 by in port 0x2. If I want to say show interface trunk, then we have these two ports, means this one port have the two VLAN allowed. Now we are good. So we have make the communications, means the logical configuration, so that can do the communication between each other. This is layer 2 switch. So if I go on the PC1 and try to reach the PC2, it is not possible right now. Let me show you. Say if I just go here and just I check the IP config and I try to ping 2020, it is not working, right? Even you go for the another PC and you just try and you just make the ping hit for 10, it is not working. So in both sides, we do not have any communication, right? Let me put the extended ping because the switch is not going to allow any communication. What the next step, guys, we have to do actual thing on the Palo Alto Firewall. So we have to make here my VLAN configuration. So let me go here and do that VLAN configuration here. So now you can see we have the single interface which is pointed toward the switch, and the same interface need to pass both VLAN, both subnet, right? Both VLAN means both subnet, because this is one subnet, this is another subnet. So we have to do that. So physical interface app, if I go and create, it is just going to allow me single IP need to assign the physical interface. So that is not going to work. So I need to create sub interface. So based on that sub interface, first is going to be VLAN 10 sub interface, and that going to be assigned the 10 network, and second is going to be VLAN 20 sub interface, for that is 20 network. So this is how it is going to happen. So let's do that. And this is how exactly you do for the router and switches as well. So this is my interface. First, I need to change this interface into as L3, because if you want to allow the interface any IP, then should be L3 interface, not the L2 interface, because we have to do the configuration on the IP level. So I'll go here and I'll go on this interface, and this is my layer 3, and I'll just click OK. That's it. There is no further configuration is going to require. After that, I will create the first sub interface, and here I will tag the number. But you can choose any number from 1 to 4 times 9, and here you have to tag the VLAN ID. But it is always recommended whatever the VLAN tag you are going to use. Let's suppose this sub interface you are going to get for the network 10. So it's better choice, go and use the 10 here and 10 VLAN tag also. That's the best practice. But tag should be exact VLAN ID. That's the mandatory. This number could be anything. It's not mandatory. Always go in the tag only. Even the switch level, you are going to create this like interface ID on the switch and the router could be anything. But the most important, the .1q tagging should be the exact VLAN ID. That's the most important. So same way we can do here. Tag, I can use any number means this tag in sub interface tag, but actual VLAN tag should be the same. Now I'll call in the virtual router. I'll discuss what is the virtual router today only. That's default, and I'll make this as a zone as the VLAN 10 zone. Okay, just for our logical representation. So I'll make as a VLAN 10 zone, and I just go and click OK, and I'll just define the IP address 10.10.10.1/24. Now let's hold on for time being. I'll update one more concept here, and I'll go and configure that another interface, that is VLAN 20. This time it is going for the VLAN 20. IP is going to be right, and I'll click OK. Now if I commit, do you guys think they are going to communicate? What else we require? Anyone can tell me what else is going to require? We created the L3 interfaces. Are my PCs are going to ping the gateway level or not? Or end-to-end level or not? So definitely we required the policy. We discussed, right? Because the one zone interface, basically this interface, which is sub interface, this is another sub interface. This is the part of the VLAN 10 zone, and this is the part of the VLAN 20 zone. So zone are different. So by default, they are going to talk or not talk. If zone are going to be different,
So they will not talk
they will not talk, right? Why they
Yes.
will not talk?
because belongs to different zone, and if we want to communicate between two different zones, then we have required a policy, security policy.
So what inside of the firewall predefined configuration available, which is blocking this communication? Do you have any kind of the
Interzone.
Yeah, inter-zone policy is there. That's the most important. Inter-zone policy is there. This policy by default block everything. But if there is an intra-zone policy, then what is going to happen?
It will pass the traffic
It will allow everything, right?
of same zone.
So that's why you can see in the Palo Alto Firewall, the zone are different. So if you go here in the policy, you are going to find there is an inter-zone policy, and this policy deny everything. So because of that, you are not able to do anything. But if you go for the intra-zone policy, that is allow everything. So my right now scenario is inter-zone. This is VLAN 10, 20. They are not going to talk to each other by default. See, they're not able to ping. So if I want to make the communication, I need to create the policy. So here is the policy, VLAN 10 to VLAN 20 policy. And this is going to VLAN 10 zone. You just go and add the subnet /24. Go here and just put the VLAN 20. Okay, applications URL action should be allowed. Right? So we required bi-directional policy. Why bi-directional policy? By default, let's understand, guys. We have the next generation firewall. Next generation firewall maintain the session. So if I create the policy from this VLAN to this VLAN, so this means this PC is able to talk to this PC. So this is the one flow of the communication. Based on the flow, firewall is going to maintain a session. So if it is requesting something, based on that request, PC is only going to reply. But if this PC want to initiate the new connection from here to here, I mean this PC want to become a client and this want to become a server, then we require the reverse policy as well, right? This is how next generation firewall or session based firewall is going to work. Make sense? So that's why always, if you are the originator, if it is responder, so you have the one-way communication means one side policy is going to require. But this is also going to be requester and you are going to be responder. Then you have reverse policy is going to require. So we have to check the both direction ping test. So we have to require the reverse policy as well. So I'll go here and I'll create the reverse policy. So this time I'll create the VLAN 20 to VLAN 10 policy. And I'll go here.
10, sir. Actually, you write there 20.
Oh, sorry. My bad. Thank you. And 2020/24. And here I'll go here and I'll add the VLAN 10. This time network is going to be right. And action is going to be allow. I'll click OK. So this is also done. Now let's do the commit. The moment I will do the commit, you will see some significant progress is going to be happen. And probably these two devices are going to talk to each other. Just wait. So you can see these PCs are start talking to each other. Means you able to ping from the PC2 to PC4 and PC4 to PC2 as well. Means both way communication start happening once I created the policy. That means my inter VLAN start working. If you go here in the live traffic, you want to see in the sessions, you're going to find the session are getting created. And this is the VLAN 10 to 20, 20 to 10. And you can see when the 20 is trying to reach to 10, this is what I was trying to explain. This is the client to server packet. Here you focus. This is the client to server means this first flow is going to act as the client. Sorry, this is the client and this is the server. Destination is server. That's the client to server. And when reverse is going to happen, then it is just server to client. So whenever you have the client and want to reach the server, you require the policy. But if you have the client to server policy, server is going to reply on behalf of that. But server itself want to initiate the traffic, then you have to again require the reverse policy. Okay. Now, I hope you understand how to do the inter-VLAN communication. One more important thing, guys. Let's you see my PCs are able to ping to each other, but let me go and try to reach my gateway. We have the IP configuration. My this PC able to ping this PC. So my gateway is going to reachable or not? How do you guys think? It should be reachable or not?
No.
Okay, good. What others, guys? It should be reachable or not? If gateway is not reachable, then how my end-to-end packet is getting transferred? Anyone know the reason why, if it is reachable, then why it is reachable? Why if it is not reachable, why it is not reachable?
Sir, actually in Palo Alto Firewall, we have to make the ping management profile. Then only to be able to ping.
Good, good.
ISMP need to be on.
So by default, that's why I just asked purposefully this question. You can see, even we have the end-to-end reachability, but my gateway itself is not reachable. Even I go for this PC and I try to reach my gateway IP address, it is not reachable. Gateway is configured on the Palo Alto Firewall L3 interface, that is sub interface, but that is not reachable. So what is the key concept? By default, there is multiple type of interfaces. One is my management interface. This is the management interface. Rest are the normal, either it's going to be the VLAN interface, sub interface, or any physical interface. Management interface, by default, your ping is going to be allowed. Your SSH is going to be allowed. Your HTTPS is going to be allowed by default. Clear? Now you guys tell me. Let me ask again. Okay, but if you talk about another interfaces, by default, ping is blocked. SSH is, means everything is going to block. Means this interface is going to block everything. This interface is going to block everything. This also. But this is a management interface. This is going to 3 services by default allow. That's why you're able to ping the management interface. You're able to log in from this PC. And even you want to do the SSH, that is also possible. Make sense? So I have to create some explicit management profile, and I need to tell my firewall, hey firewall, can you just allow this management profile on the interfaces? So this is how it is going to happen. So let me do that. So I will go here. There is my you just go in the network. There is 2 ways you can create. You can directly go in the interface, go in the advanced. Here is a management profile. You go here and create directly from here. That's the one way. Another way, if you want to create, go here in interface management and create from here. The same meaning is going to happen. So just put the MGMT profile. And this MGMT file, you select the services. What services you want to allow? HTTPS, SSH, ping. Generally, we allow 3 services. Sometimes SNMP, user ID, telnet not secure, HTTP not secure. So we do not allow that. So I'll just click OK. And my job has been done. Now go on the interface and attach this management profile. So I'll go here and advance, and I will attach this. See, it is giving the warning. By default, attaching the interface management profile, this interface you are potentially exposing in the firewall administrator interface to any party that can reach to this interface. So basically, it's giving a warning. You should not allow this, but I'm just allowing because we are in the lab. But in production, might be you're not going to be allowed. So I'll just click OK and commit. The moment I will do, you will see this firewall is going to be raised to your management interface. Just give me 1 minute, guys. So let me see the commit is done or not. Yeah, commit is done. Now if I go here and if I ping, see my management interface start pinging. If I go here also, IP config, I'm on the same PC, I believe. So This is reachable. I'll go in the PC1. This is also reachable. So we are reachable to the management interfaces. Is it clear, everyone? Like we discussed 2-3 important topic. One is how interval routing is going to be happen and how interface management is going to be allowed. Now let me show you in the management interface how the services is by default showing it's allowed. Let me show you that also. I forgot that. So you go here and go in the devices, setup, go in the interface. This is the management interface. You cannot find the management interface in this section, right? So you go here and after that you go in devices and click on here and you're going to find these services, HTTPS, SSH and ping. These are the by default allowed in the management interface. So that's why management interface, you can log in via this browser. If you want to do the SSH, it is also possible. Ping is also possible. Please let me know if any questions anyone have. Else we have to move in the next topic. Guys, is it good for everyone? Give me thumbs up. Yes, no, maybe.
सर अगर हम इंटरफेस को मैनेजमेंट इंटरफेस नहीं क्रिएट करते हैं तो हम उसको अलाउ नहीं कर सकते हैं पिंग को.
Just give me 1 minute. 1 minute, just give me.
Okay.
My laptop was about to died. So just going to charge. Yes, ask me again. You're saying like when I'm not going to allow the management profile.
Yes.
So what is going to be happen?
सर मेरा क्वेश्चन ये है कि अगर हम लेयर 3 इंटरफेस को मैनेजमेंट इंटरफेस नहीं बनाते हैं तो हम पिंग को अलाउ कर सकते हैं उसमें?
नहीं, you cannot ping to that interface unless or until
Okay.
allow the services. But you can pass the data traffic through that interface. That is going to happen. What we were doing, like my PC was able to ping from here to here, but only they're not able to ping the interface IP. But your packet is going to pass. Only you cannot ping this IP address. Clear? Lokendra?
Yes, sir. Clear.
Okay, let me stop this recording. Okay. Now we have to understand how the DHCP is going to be configured. First, you guys let me know what is my DHCP. Why we use the DHCP? Anyone know?
To assign the IP addresses is
Yeah, it was assigned automatically IP address, sir,
It is assigned the automatic IP address, right?
within the network.
So what was the problem? Which that problem DHCP is going to solve that problem? Means what was the problem which DHCP solved the problem? Any protocol we create that have some kind of the feature. Dynamic host control protocol. Why this protocol was introduced to solve any problem? Do you have any problem? Anyone know?
in the case of roaming, the user need to be change the system IP every time based on the network they are using.
So you're talking about in terms of the roaming. Okay, let's suppose I do not have the roaming requirement then. That's the valid. Yes, Tyagi, just go ahead, please. Mr. Tyagi, I can see your surname here. Your first name is not. You want to say something? You raise your hand. So one thing we understand, dynamic host configuration protocol, that's the DHCP. See guys, in earlier, we have the one method, static IP assignment, right? So let's suppose you have the laptop and that require the static IP. So every time you have to configure the static IP, means if like Anurag mentioned, if you're changing the network from one network to another network, you're roaming that, then you have to change IP address. Else it is not going to work, right? Or might be every day you're going to office, somebody should be there, or might be he need to fix the hardcode IP address on your laptop. So you are going to get daily basis that IP address. So you have to very large number of the IP address should be reserved. Let's suppose you have the thousands of the employee, right? They are working in the 3 shifts, 350 in the morning, 350 in the afternoon, and 300 in the night. So total 1000 users. Technically, if you have the 400 IP maximum, then you can cater the all shift people, right? If you have the 400 IP, then you can cater. But let's suppose every user you are going to assign an individual IP, hard-coded IP address. Then you require the 1000 IP address. Makes sense? And that always going to be assigned to the one user, and that is going to be always used by them. So that waste of the IP address, there is no proper management. And also you have to do a lot of manual work to make the IP assignment to the user. To solve this problem, DHCP comes in picture. That is known as the dynamic host configuration protocol. That is going to help you. The networks network devices are automatically going to get an IP address based on the one architecture that is known as the DORA process, right? So in this DORA process, what is going to happen? Whenever any network is going to be connected in the network, they are going to initiate some sort of the packet, and that is going to be just talk to the server, and based on that server, they are going to assign the IP address. So what is a DORA process? So DORA is basically, it's going to be discovered. One is like we have the DHCP client. Just take an example. So one is having a DHCP client. This is your PC, okay? This client is going to be connect with any DHCP server. This is known as the DHCP server. And then your DORA process is going to be start. In this DORA process, the first packet is going to be your DHCP discovery packet is going to be happen, right? So the DHCP discovery is going to send. Let me use some different color. So the client is going to send the first packet that is known as the DHCP discover. This is the first packet. Second packet, it's going to offer by the server, hey, you ask me something, so I'm just offering you something. Then based on this, this is your second packet. The third packet basically going to reply by the client. That is the DHCP request. And based on that, they are having final packet that is going to come from the server. That is DHCP acknowledgement. So whenever discovery is going to be happen, after that discovery, right, then your IP request means in this DHCP discovery message, basically it is asking for the IP request. Means can you send me the IP? I'm looking for the IP. Whosoever have the IP, can you just offer me? So server is going to offer the IP. Yes, I have the IP. I can offer the IP address. Based on that IP offer, what they offer, the PC is going to select IP address, and it will say, I have selected that IP address. Can you just acknowledge? So the selection is going to happen in this stage. And based on that, the server is going to acknowledge, yes, I'm fine. You can just go ahead and you can get the IP address. This is how DORA process is going to happen. And in this principle, the entire your communication is going to happen. That's the DORA process. Is it clear, guys? Is it clear? So one more thing, whenever discovery is going to happen, discovery packet is always going to broadcast, but whenever server is going to reply any packet, that is always unicast. So this is going to broadcast, this is going to be unicast. Third packet is going to be again your broadcast. Last packet is going to be unicast. So whatever the packet is going to be come from the server, that is a unicast. Client is always going to broadcast. But this is how it is. DORA process is going to be happen, and based on that, we can get the IP address. So now in this scenario, my Palo Alto Firewall is going to act as a DHCP server. This is the first scenario. And after that, my DHCP server is also going to act as a DHCP server, and we have to make the Palo Alto Firewall the relay agent. So let me just do one thing. I'll go in the PC. And I will go here in the network, and there is the IP address. This time I will change the IP assignment method from static to the DHCP. So this is the automatic. Once I select and click OK, DORA process get started. But there is no DHCP server. This client will never going to get an IP address. See, we lost the access event. And I just check the IP config. There is no IP. We are getting the APIPA IP. APIPA is just self-assigned IP by the device. This is the special range that is the device itself is going to get. So I'll go here as well. And this is my, sorry. I'll click OK. And you just check it. IP config. This is again APIPA IP address. So both PC are getting APIPA IP address. See, APIPA IP range is going to this. This is 104. And this is getting like 154.1. So it could be any auto configuration IP address, self IP assigned by the device itself. You don't have any control on it. This is how network device has been designed. Their OS has been designed. Whenever there is not going to get any IP address from the DHCP, they will assign themselves as IP address. Okay, my guys, it's clear. It's clear till now. Are we good for the DORA process to
Yes,
get
yes, sir.
firewall going to get the IP address? थोड़ा मुझे बताते रहो. You guys are give the acknowledgement also, so I come to know you understanding. Okay, थोड़ा बहुत ping pong करते रहो मुझे. Yes, yes. Okay, good. Thank you, guys. So now the first use case, I will use my Palo Alto Firewall DHCP. So you go here network, you can see there is DHCP server configuration is there. There's two options. One, my firewall is going to act as a DHCP server. Another, it is going to be DHCP relay agent. So let me do the first scenario. So in first scenario, I'll go here and configure the interface or network on which I want to enable DHCP server. So there's two network. One is the VLAN 10, one is the VLAN 20. So I'll go here and select the VLAN 10 first. And there are three modes. One is the auto, enable, and disable. So if I enable, that means my DHCP is going to enable on this interface. That's a very straightforward. If I disable, means DHCP is going to be disabled. Very much clear, right? But if I click auto, that means let's suppose on this network, any past or previous time DHCP is running, that is going to replace with the new configuration. That's it. So auto is going to just replace, override the old configuration for DHCP for this network. So I'll use the enable. Clear? Mode should be enable. That's the very first thing. Now it is asking, when client is going to get an IP address, do you want to allocate? Means, sorry, not allocate. Means when the client is going to get an IP address, you want to ping that. So if you click here, whenever IP is going to assign to the client, it will try to ping. But it's going to unnecessarily load the firewall. It is going to add some load. So I'll just unselect it. Least time. It's unlimited or timeout. Means when any client is going to get an IP address, how much time they are going to get a lead. Means how many time the IP is going to stay with the client. That's the least time. So I can go with the unlimited. Means always the IP is going to be there for that client till the time client is on. Or generally we do for the 8 hours or 1 day like that. So let me make as a 8 hours. Or let me make it 12 hours, 12 hours, 30 minutes. You can do anything. This is how you can do that. Now it is asking when we have to assign the IP address, what is the range of the IP you want to define? From there, the client is going to get an IP address. So basically, we have to define the range of the IP address. So I can give the range 10.10. First 10 I want to exclude, and first 9. After 10 I want to just give the range till 254. So this is the range. Means the client are going to get first IP from 10.10. Or let me make the range a little bit different. Or let me make as a 19. Okay, so from 19 to 254. So this is the pool. From there, IP will assign to the client for the 10 network. Now, if we have any MAC reservations, means you want some MAC must assign the reserved IP address. Might be have the servers, you have some special clients, some IoT devices, some IP phones, and you want that MAC should always get an IP address. So you have to do the reservation here. So if you have the requirement, you can do from here. Now this is done. Now we have the options. In these options, once the IP is going to assign the user, what the gateway you want to give. So gateway you have to give here 10.10.1 and the net mask, this is, and primary DNS you want to inherit from the firewall, you can automatically going to inherit whatever the DNS you are going to configure in the firewall. So I don't want to do that, but later we'll see how it is going to happen. And I will just click OK. This is done. Similarly, I will do for the network 20. So I'll go here. This again, I'll make as a my 0. I'll make this is also 12 or 30 minutes. You can give any number. And this time I'll give as a 20, 20, 20, 21, 254, 255, 255, 255 or 0. And 20, 20, 20, sorry. This should be the subnet mask. The gateway should be this one. Okay. I'll click OK. And let's commit. The moment I will commit, you will see my devices will get an IP address. Till now, they don't have any IP address. So I have to do some release renew and they will get IP address. Just wait. So this is done, right? And now if I go and check this PC, still they not have IP address. Go on this one, it is still not have the IP address. So there is a method you can get the release renew command. So here IP config, and you have to get the command renew. So you run the renew, it will try to initiate the DORA process and this device is going to get IP address. See, it's automatically get IP address 21. So now it's getting the IP address. Now you're trying to ping your gateway. It is going to reachable because we already assigned the management interface profile there. Now this PC is still not have the IP address. Oh, it's also get automatic. It take time, but you can see 19 IP address it's get. So now you ping the gateway. It's also reachable. So now if I go and try to ping point to point, means that PC to PC. So I'll just go here and ping 20, 20, 20, 21. See, it is reachable. This PC is reachable. If I just reverse ping 19, it is also reachable. So both sides we have the communication. And you want to see the live communication in the PC to PC in the firewall logs, it is also going to be available. Let me show you. So go in the monitor session browser, you can see here. The traffic is coming 19 and going to, sorry, this is not a valid traffic here. You just go 19 and it is going to be 21. Okay. 21 to 19, reverse also. And you go in the network, now go in the DHCP, go in the allocation. This IP, this is the MAC address, this is the host name of the PC, and this is the IP allocation has been done here. Okay. And you go for the secondary, this is the PC, this is the MAC address, and this is the lease IP has been done allocation for this particular device as well. So is it clear how to make DHCP server, my Palo Alto Firewall? Anyone have any doubt, guys?
Yes, sir.
Doubt? Yes, Anthony, please ask me.
Sir, I have already a DHCP server, sir. The separate Windows 2022 server.
Sorry.
I have already the Windows 2022 server. Okay. I have more than 25 VLANs. What I do, sir, I want to do configure again the Palo Alto Firewall or?
Yeah, this is the second step. We're going to do that. No? See, this is your Windows server, right? This yes, and you want to integrate the Palo Alto file, right? So in this scenario, I explained I have to make my Palo Alto DHCP server, but you want to integrate third-party server, then you have to do the second approach.
Okay, understand. Yeah. So I no need to do any configuration in the firewall.
No. If you have the Windows server, then you have to use the relay agent configuration, which I'm going to do right now.
Okay.
Okay. So let's take what Anthony asked. Let's suppose I don't want to create a DHCP server on the Palo Alto firewall. I want to integrate my DHCP server that's a window base or any router or any info blocks based my servers, which is in data center, remote location. So how it is going to be happen? That we have to do that. Okay. So very first thing you can see, I have the DHCP server. I believe already it's configured. Let me show you what configuration it is. Let me see. This is the router I just use as a DHCP server. So you can see there is a predefined configuration. You can just take a snapshot of the configuration, what I have done here. So we excluded some IP range from 10 to 1 to 99 from first network. Second network 22, we excluded at 199. And we created one of the DHCP VLAN and we assign this network. This is the default gateway and DNS server. Similar for 20. And then we have done this also. So just this is a DHCP configuration we have done on the DHCP server. This is a router. So you can configure your router also in the same DHCP configuration. Now, second step, I have configured this interface on this IP address. Let me show you. So if I run here, show IP interface brief, this is the IP address I configure here. Now the third step, let me show you we have the one of the default route pointing toward the firewall. So this is the default route. This is the bare minimum configuration I have done to make the underlay reachability between the server to the Palo Alto firewall. This is the server side configuration. This is my Cisco router and I create this all configuration. If you guys want to take a snapshot, you can take it for your reference or let me put in the chat. So this configuration, you have to do that. Okay. Bare minimum configuration. So I put it here. If you want to check the show run interface, this is my interface. I'll go here and this is my configuration. So you just go here and do that also. So I hope you guys understand. Now, this is normal router I configure as a DHCP server. It could be your Windows server, as Anthony mentioned, or might be your cloud-based any other server. That is also possible. Now, I go in the Palo Alto Firewall. The first I need to make the connectivity on this interface. I need to configure in the DHCP zone. Okay, so I'll go in the network. This is my interface, Ethernet 1x3. So I'll go here. I'll make a DHCP zone. One 10.1. Advanced, I'll just go and address the management profile. Okay. This is the first step. Second step, when we are creating this DHCP network, then we have to create the policy. So my 10 and 20 network also talk to the DHCP server. So require the policy in where VLAN 10, 20 should talk to DHCP zone, right? Because they need to talk. DHCP never going to talk to the PCs. They are only going to release the IP address. So DHCP to VLAN reverse policy is not going to required, but only the forward policy is going to required. So I'll need to get the forward policy as well. This is the mandatory. So you have to get the policy. I'll go here and I'll put it VLAN 10, VLAN 10 and VLAN 22 DHCP. It's like this. Okay. So let me see if I can put the policy. Yes, policy is also possible. And the source is going to be VLAN 10 and this is the VLAN 20 and this is the address 10.10.10.0/24. Now this is 20.20.20.0/24. Okay. Destination is going to be DHCP and this is the network. That's 192.168. Okay, action is going to be allowed and click OK. This is done. Now I'll commit it. This is the first step. So till now, we configure our DHCP, right? And my PC will try to talk to DHCP server and then they will get the IP address. For that, we allow the policies. Next step, we have to integrate my remote DHCP server with my Palo Alto Firewall. So what do we have to do that? Let's do that configuration. I don't know if everyone get the DHCP configuration or not. Let me put, I believe I sent to single person. It's not going in one go. Okay. So now it's done. Okay. So let me verify we have the reachability or not. So I'll go on the DHCP server. I'll try to ping my this IP address should be reachable. Yeah, it's reachable. If I try to ping my 10's IP address, means the gateway address should be also reachable. But it is not going to ping because the reverse policy is not going to allow. So that is not going to pingable. But my firewall should be able to reach. Let me try to ping my firewall. So ping source 10.10.10.1 and host I want to ping 192.10.2 should be reachable. See, I'm able to reach. And if I just go in the 20 also, because we allow the policy from the firewall side, it is also reachable. So we are good. Now let me go in the firewall and go in the network, go in the DHCP. This time it was relay. Sorry, DHCP local server, but I need to configure my relay. So relay, you have to go here and you have to select the interface for which I want to configure. This is the 1/10. So I'll select it. Then I'll put my DHCP IP address. My DHCP IP address is 192.168.10.2. So I'll configure 192.168.10.2. The moment I'll click OK, it is going to throw an error because you already configured this network as a local DHCP server. So you cannot configure again relay. So you must have the one choice. So I need to delete these all two first. This is the minimum requirement. You have to delete it. Okay. Now deleted. Now go and enable the DHCP relay. That is going to be possible. So I'll go here. I'll go 10.10.10.1/24 and I'll click OK. Sorry, I need to give the 192.168.10.2/24. Okay. What is IP address? So .1 I given here. Let me try one more time. What happened? One 192.168.10.2/24. Oh, I need to just give the IP address, not subnet mask. Sorry for that. I need to give just IP address, not subnet mask. I was doing wrong thing. So this is done. And I'll go here and give this one. This is also need to be configured. This is also done. Click OK. And after commit, you'll see right now the PCs have the IP address. Let me show you. 19, okay? And this PC have the IP address 21. But after commit, you are going to get a new IP address range, which is going to come from this range. Means the first IP after 99 for the 10 network. Second IP for 20, that's after 199. So this is how it is going to happen. And I'll show the leads also. So let's wait. But this time, once the packet is going to reach my Palo Alto Firewall, it is going to relay to my DHCP server, and DHCP server is going to further release that packet. So it is going to reach to my end device. So now it's done. And if I going on the PC and try to see, if I try to release and renew the IP address, I just release and I renew the IP address. So it will try to get a new IP address. I will just do this also. Release and renew. See, this get the new IP address 100. Earlier it was as a 19. Okay, and now it's get the 100. This must be 200. Let me show you. Yeah, this is a 200. And still you are going to ping 10.10.10.100. It is going to reach. See, I have the communication. You go here and try to ping 20.20.20.200. It is also reachable. And now go here to DHCP server. Show IP DHCP leech. IP DHCP bindings. You are going to find these two IP had been released and they have binded with the different MAC address, and this is a release time, and this is how it is happen. Is it clear, everyone? Is it clear?
Yes, sir. Yes.
Okay, so what we can do, let's have a 5-minute break and then we can connect by 11:20.